Thank you very much, guys. Thanks for coming along. So yeah, we are City Quest. I'm Rob. This is Rajinder, Nikki, and Kate. So let me just work this out. So this is our app, which is a multiplayer city-based treasure trail. Basically, it's a game where you can go on a treasure hunt style game, where you'll be given a series of location-based challenges to play against your friends, family, whoever. And these will be in the format of image recognition, questions, all sorts of things. And yeah, we also have the admin side of the app, so you can actually create things, etc., etc. But I will talk about that in good time. So just to give you a quick run through of actually how the app works in this 2-minute video, which is not a lot of time to put 2 weeks worth of work into. So bear with me if I sound like a bit of a screen reader, but it will be okay, hopefully. So let's go when it loads. So yeah, this is the main screen. You can join a game, create a game. We're going to select the trail that we want to go on. You would give the game a name, give yourself a player name, and then you would select how many players that you want to play the game. After that, players can join, given the pin. So Rajinder's joining here. And then when all the players are in, the game will automatically start and you receive your first challenge. So go to Manchester Victoria and view the challenge when you arrive. So initially you'll go to a map screen. It will give you the location, what you need to go to. This is a live location of yourself, so you know where you are and how far apart you are from the desired location. You can see progress updating, which is other players completing each challenge to see how you're doing against them. This is a draw menu which will allow you to look at various different things. This one is information about the place that you're going to. So it might help you with the question, it might not. When you think you've got the right answer, you go back to the question screen, put the answer in here. Hopefully this one will give us the correct answer for video purposes, but here we go. Correct, you get the new challenge, repeat, repeat, repeat. So you'll go through this series of different challenges. Whilst you're doing this, you can flick between any screen you want, again, checking progress. Rajinder's just caught up there. This is an example of the tasks that you've done. So you can see how many you've done, where you've been in the past. This is an example of the image recognition, which we use. So find a picture of the undamaged post box when you think you've found it. Put this in, submit it. This will ship it off to see whether the image is correct. And it'll say, yes, correct. And then I have won the game. And I can create another game or wait for everyone else to finish. So that's the game side. We also have the admin side, which you can actually create and edit and delete things. So it's a short video of this. So yeah, you log in as an admin. You can view which trails are available. You can delete them, you can edit them. You can also just, well, it kind of speaks for itself, this video, I'm not going to lie. But yeah, to be honest, what I want to say is, with the actual app itself, that was a short video. But if you do want to give it a go, play it afterwards, after the other team have done their presentation, feel free to just hit us up with that and we can sort it out, because it is quite proud of it. So yeah, onto the tech choices from now. There you go.
Hi everybody, I'm Rajinder, and this is an overview of the tech stack that we've used for our project. It looks slightly complicated, so I'll explain it a bit. So when you use the mobile app, it serves as a client to make API calls, make calls to our API server. The server then make calls to our database, or it can make calls to the third-party APIs. We've used Google for ours. Similarly, for the web app, when you use the web app, you make calls to the API server, which then make calls to the database and the Google API. Both the mobile app and the web app, they both directly interact with Firebase storage to store the images, from where we can get the URLs, which can then be sent to the backend for the image analysis. So now moving on to the details of backend. We've created the server with Node and Express, which we have been using from the start of the course. We've used Google Cloud for image analysis and locational data. We preferred Google Cloud because of its accuracy of image analysis over IBM Watson. we've used IBM Watson before, but Google Cloud seemed to be more accurate with image analysis. It was quite easy to use, only that 3 of Nikki's accounts are related, like connected to the course that we are making to it. Well, yeah, the Cloud Firestore, we've used our database, we've built our database in Cloud Firestore. The initial thoughts were to use SQL because our data was quite relational, as in the routes were connected to the locations and the locations were connected to the challenges. However, as we were using images, we had to store images in the back end to make calls to the Google API, and also we planned to use real-time updates. Firestore seemed to be a better option. And as I've mentioned before, we've used Firebase to store our images. Finally, we've deployed the server on Heroku. We've used this before as well. It was quite easy to use, low configuration. So as you could just deploy your app in no time, it left us with more time to spend on the development, actually, which was quite important for us because we only had like limited time. So yeah, now moving on to the content.
Thank you. Hi everyone, I'm Nikki, and together with Rob I worked on the front end. So we built our mobile app in React Native, and we chose this because it allowed us to use JavaScript rather than having to learn like Java and Swift, so we could develop in one language for both iOS and Android. We decided to use Expo because we could just build one app rather than having to build 2 versions, and it would work on both platforms and be compatible. We did find there were a few differences between when it ran on Android and iOS, but for the most part it worked pretty well. So both Expo and React Native were both completely new to us, so we did spend quite a bit of time in the beginning reading the docs, and we had previous knowledge that React Native, although you think it might be similar to React, we had heard from previous groups that it wasn't going to be, so we kind of knew that going in. So before building the app, we spent a couple of days spiking some of our most important components, like the map and the camera, because we needed to be able to interact with the user's native apps in their phone. So what this means is that the app uses Apple Maps on Apple and Google Maps on Android. So even though they're using different maps, they still both get the same great experience, as you saw from the demo. The next thing we worked on was the navigation. We really wanted to get this done straight away because we'd heard that it was quite tricky, and ours especially, we've got 3 nested navigators. So we used React Navigation to build this, and just statically to start with before we started adding in any of the components, just to get an idea of how the app would work. The admin side of the app is a web app and built in React. We decided to use this because we already use it in the course to build our Northcoders news. So it was already familiar, and it just saved time when we were building it. We didn't have to learn anything new to do that. It was still quite tricky because we were having to interact with the Firebase, which was obviously new to us, but for the most part it was just a quicker option. Both the front end and the back end interact with our back end API, but the admin app, as Rajinder said, also interacts directly with the Google API. Having this admin app really makes our app more extendable because we can add challenges, delete them, edit them, and it means that we can use this anywhere in the world. So like you could have a city council who might make a challenge for like a tourism purposes, or yeah, basically if you're going on holiday with your friends, you could set up one. So it just gives you more options that way. So that was good. So to start the project, we started out by making our user stories, and we put all of these into our Trello board and split them in the game, the admin, like the login experience and stuff. And then we split them into small tasks, which we could color code based on who was going to be working on them. We used it to keep track of where we were up to, so everyone could always pick out a task that needed doing if they weren't sure. We did start out using daily stand-ups, but we did find that as we were quite a small group and we were all working quite closely together, that often we all knew what was going on already, so we were kind of having a stand-up all day really, but we did sometimes still meet just to kind of make a plan for the day. Most of the time we worked in pair programming. We tried to swap around a bit between front end and back end so that everyone could get a bit of experience in both, but it was quite difficult because we were learning these new things that if you'd spent 2 days learning something, it was quite tricky to swap The paired programming was really good though with that, because you've got 2 people looking at it instead of just one, and you've always got that extra eye to help you if you're stuck on something. With the testing, we did have limited time, so it's not everything is fully tested, but we did some unit testing on certain functions, and obviously we did a lot of user testing of the app. We had to put in a few little shortcuts within the game so that every time you wanted to see if some styling had been updated, you didn't have to go through and answer every single question and wait for every other member of the team to join the game. So we had a few little tricks up our sleeve there.
Thank you. Okay, I'm Kate. Hi, and I'm going to talk about challenges. So we did have a fair few challenges. Mainly it was the time was against us because we only had the 2 weeks to do this, and we did take on quite a lot. We also took quite a while coming up with our initial ideas, so we probably could have slimmed that down a little bit. Very early on, we lost a team member as well on the first day, so we'd sort of done 5 people's worth of work planned, and then we had 4 people to do it, so that sort of set us back a little bit as well. We got around this by prioritising tasks, and if we got stuck on anything, we just sort of moved on and adapted the design to be able to keep the functionality as much as possible, but not take so much time and not get hung up on it. We're also using a lot of new technology here. So the Firebase, Firestore, React Native, the real-time maps and the camera, they were all completely new to us. We'd never used any of those before. So it did take quite a bit of time to get used to those. Again, we approached this by just reading the docs really carefully and taking time to spike things. With the real-time data as well, we had originally planned to do everything in real time, so the player progress in real time as well, which is why we used the Firestore. But we kind of realised that we'd need to have the Firestore communicate with the server and also separately have WebSockets coming from our client to our server. So it was actually a really big task to get all of that working in real time. After playing with it for a little while, we found that it was just taking too much time. With a bit more time, I'm sure we'd get it working, but we approached it with set interval instead and made API calls to get that same behaviour, but without having to use the WebSockets. What went well? So we used GitHub for version control, and that went pretty well. It became clear this is the first time we've worked in a group together, and it was definitely needed the version control for getting that to work well. We also, I think, communicated quite well as a group, so we didn't really have any problems with the dynamic in the group. I think we all worked really well together. We also, like I said before, we moved on when necessary, like try not to get stuck on things too long, just adapt the design if we need to. What we'd change if we had a little bit more time, with hindsight, we could have used different technologies. So things like the Firestore, we didn't actually use the real-time data in that, and we ended up using the cloud, Firebase Cloud for the photo storage. So we could have used SQL with hindsight, but again, they're all new technologies to us, so it's the benefits of hindsight there. We also left it fairly late in the process to merge some fairly major components like the camera and the maps, which are all working independently. It might have been helpful to have them merge a little bit earlier on in the process. We would also, if we had more time, refactor a little bit, so get our code a little bit drier and put a bit more testing in there, just best practices really. But overall, we're really, really happy with it, especially as we built an app, a web admin server, 2 databases, numerous API calls, all with new technology, and 4 team members in 2 weeks. So we're pretty proud of that, really. Especially as 3 months ago, we wouldn't have known where to start with something like this. So I'd just like to thank everyone for coming today, especially like the hiring partners and family and things like that. And thank the team members as well. They've all been really, really great. And then the staff as well for helping us through this whole process. Okay, any questions?